Welcome to our timing workshop. Today we will discuss some technical topic and how the organize transactional behavior between the database and messaging broker. We'll discuss the pros and cons of each way. So for people who know, so don't know me, my name is Andrei Shakirin. I work in the Tanzu Labs and participating in quite a lot different custom projects with different situations, and really happy to share my experience with such technical challenges with you, and also discuss with your experience. The plan for today is to define the problem, what exactly happens, why we need this something to think and something to solve. Analyzing naive ways to resolve the issue, ad hoc approaches. Then I represent more or less standard transactional outbox pattern. So the way how it's recommended to solve, and make my small personal improvements of that. And we can also, on the end, make some conclusions and start our discussions. Okay, let's go ahead. Problem. It's quite often happens, so in my project at least, that you need to somehow change something in the database. Let's take into account a relation database as in most cases, and send an event, send a message in message broker. And these two events should be consistent. So you need to write something to close the transaction in the database and send the message, and either they should be both successful, or should happen nothing, not in database, not in sense of event. So the example, for example, we have an e-commerce case. We have some checkout and payment, and customer close the checkout, say order, and we need to update the status of checkout and log it that customer could not change anything in the order anymore because it's closed and the payment process started. And from other side, we need to notify payment service with some kind of event that payment service ask for customer login into the payment system, choose the checkout options, and so on. So we need to go through the workflow in the next steps. But very important that we need to also make a small updates of the checkout, set status, yes, is in process, in payment, and we kind of prohibit a few next further changes in the order. So you could not remove items or add items anymore because you're about to pay. All right. This is case from the e-commerce domain, but a lot of other cases then database operation and sending event should be atomic. Just for curiosity, just send a like or write a short message if you have such kind of situation in your projects. You ever need such kind of functionality and guarantee atomacy. Just send a like if you ever seen such kind of requirements. Nobody. Interesting. I have it very often in my projects. Okay. So let's try to resolve it. Yeah, it's exactly the problem that database and queue should be consistent. Yeah, so either we have a changes in database and we have a message in queue, or we have no message and no changes in the database. Let's just try just naive. I would like to send events somewhere inside the transaction. So transaction is still not closed, and I send my event. So what happens here In successful case, it's all green. Yeah, so event successfully sent. My updates of the database are successful. We commit the transaction, and it's fine. But what happens if we sending event, but for some reason committed transaction fails? What happens in this case? Yeah, the transaction will be completely rolled back, including our changes in the status, but event is already sent. Event is already in queue. Yeah. So we have inconsistent state in this case. It's our first try. Okay, so let's make another try. Let's send event after we commit the transaction in the database. So we make some update user, update statuses, committed transactions, send an event. And again, if the things are works smoothly, yeah, they have no problems. We have consistent state in the database in the queue. What happens if the transaction commit fails? It's still okay, yeah. So the transaction fails, but we also don't send an event. So we process the situation, and we have still consistent state. We have no update in the database, but we also have no message. It's nice. But what happens in the last case if they successfully commit transaction, and afterwards our sending of message fails? That's a problem because we already committed database. All applications or all services see the updated status, but we cannot send the message. The message is not in the queue. And even worse, we cannot easily repeat it because we have no all information. We have a handler exception in some handler, but we have no information about the message, how to repeat the same. And this is really a problem. This state is inconsistent. So the naive approach is either we do it inside the transaction or we do it after the transaction. The both approaches unfortunately don't work. Yeah, so we need something different here. How to resolve it? That is, there's basically this problem that one problem is that event is not durable, and so if they hadn't read the message queue, we completely can lost it. We have no information how to repeat it. And even if we have some information in memory, for example, we have some object in our method and method fails, we still have some object. But what happens if the server is shut it down in this moment, or is in catastrophic scenario that we have the server is not reachable anymore, we lost information memory and the event is still not sent. So the memory information memory for the event is not enough to be 100% true. Of course, it happens not always, quite rarely, but still we have no 100% guarantee that the event will be sent. So we need some kind of different solution, and the solution for that is outbox pattern. That's distributed system patterns provides. What is the idea of outbox pattern? I try to explain. So the idea is the following: that besides the normal tables where we save our status or make some other updates, we create additional table with name outbox. Therefore, this pattern has name outbox pattern. And in this table, application will save all information necessary to send an event. And this happens in the same transaction as the status. So we update the status, we update some information, some business information what we need. And in the same transaction, we update or we create new entity in the outbox pattern and say, yes, we need to send event with such information, but we don't really send in this event. Parallel to that, we have kind of flush loop process that works independently of the main application, and it scans. Normally it's time based, so do it every minute, every 5 minutes, or one per day. This process scans this table and sends an event. After successful send, it also writes the status that the event is sent, that it not the next time we will not send it twice. What is the difference with the first approaches? The main difference that we have now persistent information about event. And even, of course, this process could also, sending event through this process could also fail. Yeah, so we could have a problem as well here. But we have the whole information about message. We can resend it, we can retry it, or we can retry it on the next loop. So we have unlimited possibility to retry our sending into the message broker, and one day it will really send. Yeah, or we need to repair our broker manually if it's don't work at all. So that's the problem of infrastructure. But kind of short hit up doesn't so we can work with that. So if the first send is unsuccessful, on the next loop, this event will be sent. This is a way how to resolve it. Let's see a little bit more technical level. So what happens in this case is our order service. We make some updates, business updates in order table. And parallel to that, we insert new record in the outbox table. Our message process will read this information from the table and send event to the message broker. And very important, on the end, will update again the entity status that the event is already sent. So by the next run, it just scans the outbox table, find all records without sending status, and send all the events. That's how it works. So of course, the successful scenario will still work. So we application will commit business transaction, commit outbox table, and outbox sender will send the event. In the fail case, if this transaction fails by application transaction, nothing will be saved in the database, nothing in the outbox table. We still have consistent state. If the sender outbox has a problem to send a message, we have eventual inconsistency. Yeah? So we have for some time inconsistent state, but by next running, we again try to resend this message, and will in the one day it will be successful. Let's move into the pros and cons of the outbox.
Yeah, Andrei, sorry, we have a question. Yeah.
Yeah, hi, Andrei. Thank you for your introduction. Like, I just wanted to ask a question before you explain, like,
sure.
Because it will be probably cover my question, but I'd like to think a little bit before. Yeah, like, my question is, does it make sense to use an event-driven approach at all if we have this strict requirement that, like, we should guarantee that this operation should transaction. Yeah, like that if we can't lose this event, or we can't. Maybe it will be easier just to save to database and then have cron job that check and do some work without all this pipeline, these events and hangers.
Yeah, sure. So the question is if we have such kind of, we need to guarantee that the data in the database and sending event should be transactional. Does it make sense to use event approaches at all in this case?
Yeah.
Perhaps yes, perhaps no. So it really depends on your case. If the event sending event is still helps to decouple your service from the another service. Yeah, so you just send the event with some business information on that, and you can have one service or can have multiple participants, multiple services who listen to the queue, listen to the topic, and somehow to react. So basically, this part is not directly related with what happens when we send an event. It's just internal requirements in the applications that besides sending event, we also need to change something in our internal persistent storage or in the database. So event-driven architecture, event-driven approach could make sense. Sure, yeah. Could be the case that is not necessary, and you can do it synchronously. For example, you can, for example, another service pull your REST API and check if the status changes and react on that. Yeah, it's valid approach. I would not normally recommend that another service directly go to the database, because when we couple two services in the database level, so you need to have a schema, the same schema. Normally it's anti-pattern in case if the services are working in the two different bounded contexts. Yeah, then it makes sense to separate the database. But of course, yeah, of course, you can. Another service could, for example, use the REST API to check this data, or if you realize WebSocket protocol, perhaps you have automatic notification of another service. Yeah, it's your choice regarding the requirements of your case. In the case of the e-commerce order service, I would like to decouple that completely, and I use the message queue for that.
Yeah, this reasoning is completely reasonable. I had another, actually, a little bit schema in my head. Like, if I understood correctly, that we we update our database, we update like another table with events, then we have job that reads these events and removes them from database, then it publish this event into the queue, and then somebody subscribes on this event to do some job.
Yes.
Yeah, and I thought that what's the problem with like, we don't want to couple services, but we can have this handler that read not queue but database directly. Yeah, that we have this job that read the same thing, but instead of pushing event somewhere, it calls like this service. And then we kind of
course, of course, but you have then the whole disadvantages of synchronous communication. Yeah, you can of course call the service, but what happens, for example, if the service doesn't answer?
Yeah, I mean, in 5 minutes it call again and again and try to reach it.
Yeah, so or you have the service are under load and it cannot proceed so much calls as you send. Yeah, so so the service resource of the service is limited. Yeah, and you send there's a lot of things here in the table, and you send 1,000 of event in the one time, and service cannot proceed it. Yeah, and will fail. In the queue, just you put it in the queue, and service can proceed with own performance, yeah, with their own speed. This is a typical advantages the asynchronous communication using the queue and direct REST asynchronous call. And also, if this fails, for example, you have operation in another service that fails. Normally, message brokers has automatic inbound out of the box mechanism to repeat. So the message broker will resend the message if it fails. For example, it will send after 1 second, then after 5 minutes, and after 10 minutes. And if still processing is not possible, that put it in the DAL queue, but it's a guarantee that the message will be not lost. This is the criteria to decide. Yes, sure. You can use this approach with outbox table to communicate synchronously as well. Yeah, sure. But you will then have all disadvantages of synchronous communication. Let's go to the pros and cons. The pros of outbox pattern is quite obvious. We can guarantee atomacy and durability by working with database and with event broker. Also, one additional advantage of outbox pattern, you can group event a little bit. So you don't do it in the same moment of time. You can wait a little bit when the events comment. So yes, we'll send not only single event, you can group the bunch of events. For example, you can send as one message 100 events or 1,000 events. Disadvantage, quite sure we need to support additional triggered application or job. Very important here, normally I suggest to deploy this job separately. So not make this new process in the application, but deploy it separately. Because normally it should scale differently. And normally we also, it's enough to have only single instance of this job. Because if you have multiple instances, the processing is very tricky. You need perhaps to have a master selection to guarantee that only one job do it. And you have a possibility, if you deploy it separately, you have a possibility to scale to keep only one instance of this job and scale application differently. But in this case, make absolutely no sense to split the database. So this job will work with the same database as application. And exactly this case when the two microservices working with the same database, and it's okay because they both working in the same bounded context. Disadvantage, events can be duplicated still. Yeah. So in which case events will be duplicated here? If we go a little bit back, it happens. It could happen here that we send a message successfully, but this process, by updating the outbox table, this transaction is failed. Yeah. So it tried to update the status, but it's failed. And exactly in this case, by next run, we see the status is still not sent, and we will repeat the sending again. So it's possible, still possible, this pattern that we duplicate the message. Therefore, it's very nice if the services, the target services, is idempotent and has not problem if they receive message more than one time. Events will be sent not immediately. Yeah, that's also huge disadvantage of this pattern because we have time triggered job and perhaps the event we have already updated. So updated our status table, but message will be sent in 1 minute or in 2 minutes or in 5 minutes, depending on how often this job is run. Also, if we group we group a lot of events, we can overload the target service. Yeah, what I said. That's exactly the danger if you use synchronous communication here, where then the service would say, it's too much for me and I cannot process it. Need to be careful. But exactly queuing stuff, queuing the events could help because we can accumulate events there, and service will proceed it one-to-one. So perhaps makes sense to avoid to aggregate too much events in one bunch. That's not overload the target service. And of course, if the service B and C still fail and lost the messages, then possible to still have inconsistency between our application and target services. This is regarding the outbox. In my practice, the most difficult problem was this one. So event will be sent with certain delay because you either need to run it very often, need to run every second or every 10 seconds, or you cannot guarantee that the message will be sent with delay, and sometimes this delay is critical. Therefore, I have my small personal improvement, or let's say another option of outbox pattern. It looks like the following. So basically, the idea is the same. We have still this outbox table. The difference is that the application is also responsible to send the event. Yeah, so application makes the updates on the database, writes the outbox table, insert the entry in the outbox table, but it also tries to send the event first, And then if event was successful, let's update the event table and said the event was sent. In case if it's unsuccessful, yeah, then we don't write anything in the table, and then the job is take his responsibility. And if the main application cannot send the message, the time to get job will find such kind of events and resend it. But it only happens if the main flow is fails. Yeah, so we still have guarantee, but the most 99% of the message will be sent in the main flow. So let's look what happens if some steps are failing. So if update entity sending status fails, all consistent because we don't update the database, and of course we even don't try to send the events. If we commit the transaction successfully, but send events failing, we still have our outbox table with unupdated status, and then is responsibility of our job, sender job, to reach to find that kind of events and resend them and send them. So in this case, application even not try to send it because sending event fails. But based on this outbox table, sender job could recognize such situation and send the event. The next situation is even more interesting. Application update commit transaction successfully, send event was also successful, but the last event status update so fails in the table. In this case, again, we have a job that recognizes the situation and resend event, but unfortunately, this event will be sent twice to the target. Yeah, so we cannot guarantee that it sent only one. It's possible to have situation when it will be sent twice. So the target services should be ready for that. What is the pros and cons of this approach? It's kind of again guarantees atomic endurability for database and transactions and events, and it's resolve the problem of the outbox pattern that of course we could have some events it will have delay, but the most part of the events will be sent immediately when application tried the first time, so without any delay. It's still necessary to support additional job, yeah, time to get a job. This disadvantage is the same. Events can be duplicated, yeah, it's also the same as this outbox pattern. Again, inconsistency is possible when service being sick and fail and lost the messages. And one disadvantage is sometimes critical for the architecture. Unfortunately, we need to implement sending message mechanism in the both places. Yeah, we need to implement it in the application, and additionally, we need to implement it in our job. So it's kind of single responsibility principle break, because in the outbox pattern, only job was responsible to send the message, has dependency on the message broker. But here we need to implement this functionality twice. We need to implement it in the application side, and we need to implement it in the job side as well. This is the main disadvantage of my approach. And also, it's not possible to group event. It could be also advantage. So we not load the target service, but we need to send a message, physical message per event. It's not possible to group it because we do it in the application. Any question to that?
Yeah, Andrei, I have one question regarding those delays. What if we have a situation that two actions applied, one after another, to change the status? First action change status to, I don't know, status in progress. Second one change the status to status ready. First change of status arrive to some incorrect behavior, which lead to situation when this event will be sent with delay. And after that, we have a change of status to finish status, which could be applied without delay. Does it mean that it could be overlap and incorrect order of execution?
Yes, it's possible. Yeah, in this case, it's possible. If the first one is, of course, it will happen very rarely. It will happen only in case if the first, let me go a little bit
First
back.
failed to go through emergency approach.
Yes.
Second, not failed. But in this situation, it's not.
Yes.
Data will not be consistent.
Yeah, if it's really two different, let's say, two different steps in this case, then it's possible to have a wrong order. You're right. Yes.
Yeah.
So if the first one fails, and we leave the first one to the emergency job, and for second one will be successful and application will send it. Yes, when we can, very rarely percentage of cases we can have a wrong order of the message as well here. Yes, it is so.
Yeah. So this second approach with emergency, it will give us a bit more speed.
Very good.
But not always data will be consistent, or we need additionally some integrator an approach to take into account some
exactly we need to
time when it's executed.
Yes, we need a message ID, and we can sort it somewhere on the receiving. But yes, it's also one of the disadvantages of the emergency job approach. Then if we send a not only a message for one case, or let's say our message is not independent, but there is some kind of workflow with events. Yes, and we need to guarantee the order. Yes, but by the way, the order guarantee is anyway very difficult if you have multiple listeners on the receiving side, because it could happen that one listener for some reasons a bit faster as another, and you still could have a situation when your read message early so the message was sent later, but will be written processed early. So if you have, of course, only single thread listener, then it works. Yeah, but in this case, the performance would be not so nice. If you have multiple threads to listen the events on the receiving side, you still could have a problem with the order of the messages. Yes. Therefore, for example, I think we have some 1 year ago presentation from Dmitry Belyaev, former colleague of me, and one of the anti-pattern was to put all information about entity inside the message, exactly because of this reason, because the order of message could be not correct, and you can on the receiver side you can receive some stale information. Instead, that better approach to put just ID into the message, and receiver on the other side could load necessary information from the service based on this ID. This was main reason. But it's very good point, Andrei. Yes, so there's an additional disadvantage of emergency job that we can break order. In the outbox pattern, it's not possible because we can write in outbox table one after another the entities, and exactly in this order the job will proceed. Yes. Basically, I think it's even possible in the outbox pattern to have a breaking order. Let me think, because here, let me think about that. I think it's also possible to have breaking order. Imagine we have outbox table, and for some reason one message is fails. Yeah, early message. But you can okay, if you continue to read another messages and send, you can still you can still break an order. If of course your implementation say if you have a fail one failure, then you stop, proceed the another entities, and just rerun it and try to the next time. In this case, you're more safe regarding the order. But if your implementation just skips the error and try to go further, it's still possible to break the order of messages. I just should mention that there is also a bit old-fashioned approach to guarantee the transaction. I think is still supported by Spring Boot. So if you use a GMS broker, you can use activate this external transaction manager, and idea is to group your GMS operation and database operation under a single transaction manager. And in this case, it just guarantee by their library that they send in the same transaction. Of course, disadvantage is a very high level of coupling, sending message and database, and you're bound to GMS technology only. Therefore, I not recommend to use it, but if there are some situation where you can break the rule and still this mechanism is still available in Spring Boot. Yeah. Conclusion. So there is the problem. It happens very often in my projects, and there is established solution for that. It's out-box pattern that guarantee basically atomacy, or let's say is eventual consistency between database. When still possible to have a time when the database state intervenes inconsistent, but in the end, system will resolve it, and the state will be on the end of the day. The state will be consistent. And yeah, the outbox pattern is not for free. It's requires some additional implementation efforts, components, support, database tables as well. And there is some variations how to implement the outbox pattern. If your business case cannot tolerate, and it really depends on your business case. So if, let's say, if the order, you can ask if the consistency is necessary first. If if for you it doesn't matter, for example, you send some events for statistic analyze, and if something fails, it doesn't matter. So you don't need to implement it at all. Yeah. And then you can ask if the delay is critical for me. If yes, you can look into this emergency drop solution. If not, use the classical outbox pattern. If the order of message is critical, then again, make a choice between classical outbox pattern and emergency drop. So depending on your requirements. For some cases, of course, like Pavel asked, perhaps messaging and queuing not necessary at all, and I quite satisfied with normal REST-based synchronous communication. Yeah. So it's also a solution. So really, it depends on your functional and not functional requirements. You can choose one option or another. So the bunch of options is here. Cool. Thanks a lot, and see you next time.